Of course, big energy releases are interesting and important, we know, but the reason they're so important is that the sun, when gases and plasmas reach the explosion point and energy is released, spew out huge clouds of plasma into the solar system. They travel to the Earth and carrying magnetic fields from the sun along with them. And then they interact through the same reconnection process with the Earth's magnetic field and start transmitting energy from the sun to the Earth that stores up energy in turn inside the Earth's magnetic field, the Earth's magnetosphere. And that gets stored up in the magnetosphere to the point where eventually reconnection allows that energy to be released locally inside the magnetosphere. We have huge heating and acceleration of the plasma. The plasma is flung as if from a cannon by these muscles, if you will, the magnetic muscles of the plasma universe. And the original process that flung plasma from the sun was the same thing. It reaches the Earth and disturbs the Earth's magnetic field, stores up energy in the Earth's magnetic field, and then it releases energy in turn. That energy ends up in space around the Earth in forms that are harmful to spacecraft and communications, and even generating currents in the Earth itself and in its ionosphere that trip circuit breakers and power distribution systems. And we have blackouts that result from energy releases that started at the sun, started up as energy stored in magnetic fields, and ended up as energy imparted to the Earth's magnetic field, and in turn generating electric currents that disturb all of our technological systems. So we're all a lot more vulnerable the more that we depend on space technology. Well, we've become a technological society with many investments in assets in space that depend on sort of routine, normal operation, and we get to depend on them. GPS systems in particular are very much at the forefront of people's awareness right now, with everybody carrying a GPS receiver practically. We can't really protect systems from really severe storms any more than we can from tornadoes, but we can understand when the storms are coming, try and take what evasive action we can. And really the goal may be fundamentally to understand when things happen, when systems fail or misbehave in space, what's causing that misbehavior, and do we accept that as a temporary condition and that will get better, or is it going to be a more permanent failure? So we'd like to have set up a planetary or heliospheric weather system like we have for a national weather system that tells us what kinds of weather to expect at any given time and what kinds of things are going on that may be causing interruptions of service and other effects in the system. What are we likely to see a blackout? Do we need to worry about how to deal with that emergency? We're all connected to the Earth chemically, and I became interested in this field through being curious about how the Earth became as habitable a place as it is, with oceans and agreeable atmosphere for us. And of course, a lot of that's just adaptation on our part, but we have a very unusual planet. We've searched the universe for other planets. We're discovering planets around other stars all the time. None of them are remotely close to the Earth in terms of habitability, and I became very curious as to how it could come to be that way. And one of the factors that I identified as being important is you could be gaining and losing material from space. The early Earth didn't have oceans, it didn't have an oxygen atmosphere. I'm not saying they were gained or lost to space, but a lot of material over geologic time has been gained or lost from space, and I became interested in that. And then I realized that the main energy source that's going into our atmosphere and causing it to expand and escape into space is this muscles of the plasma universe, if you will, and it's all driven by reconnection between the sun's magnetic field and the Earth's.